Hello everyone. Today we'll be discussing CyberArk architecture. So welcome back. Last session we covered the fundamentals, what a privileged account is, why attackers go for them, and the risks you're exposed to without a way to manage them. So today we're going to go one level deeper. What CyberArk actually is architecturally, and also CyberArk recently changed the name to Indira. So the CyberArk, Indira, same thing now. So here's the first thing you gotta get in your head. CyberArk is not one tool you'll install on a server and walk away from. It's a set of components, each with its own job, and none of them gives you real security on its own. Take any of them out and the workflow breaks. So today we're going to be walking through each component and what it does and how they talk to each other, because once this architecture clicks, everything else in this course is just detail on top of it. So we'll be talking about the vault first. So every CyberArk deployment starts with the same first component, the vault, also called the Enterprise Password Vault or EPV. You'll see both names used interchangeably. So think of the vault as a single repository underneath everything else. So it's where privileged accounts live. So where every account you onboard gets stored here. It's where policies live. So the rules that govern how the accounts behave. Logs live here. So it's the record it's a record of every action taken through CyberArk, the session recordings, the actual screen captures of what users did, and the configuration data lives here, where the settings for the whole environment. So the vault runs on its own dedicated server. It's the database, full stop. Nothing else in the architecture stores data independently, and everything else writes to the vault or reads from it. So why not just let the users log into the vault directly? Here's a natural question. If a vault has everything, why not you just have users authenticate straight into it? Walk through what happens without any of this in place. A user wants to reach a Windows server. They open a native RDP client. They type in a server's IP, and they type in a privileged username and password that they already know, and connect directly. No CyberArk involved at all. This is the exact problem from last session. The connection is invisible to any central system, and the logs on that server that will only ever say the privileged account did this, never which specific person was behind the keyboard. So the fix looks obvious. Onboard the account into the vault, give the user access, done, and that's closer to correct. The user now logs in through CyberArk, so their session gets tracked, timestamped, and mapped to their own identity instead of hiding behind a shared account. But there's a flaw with stopping there. The vault is a single repository holding every onboard account, potentially thousands of them. If you grant a user direct access to a vault to log into the vault, and the same database that holds every account in the organization, once user logs in, turns into a door onto everything. This is why CyberArk segments data into safes, logical containers within the vault that scope what a given user can actually see. But safes alone don't solve the deeper architectural issue. Users still shouldn't be authenticating directly against the database layer at all. That's what the next component fixes. And that is the PVWA. The second component is the Password Vault Web Access, or PVWA. PVWA is a web portal, a front end. Users get a URL, they navigate to it, they log in there instead of touching the vault directly. Critically, the PVWA itself stores nothing. It has no database of its own, and every time a user logs in, PVWA reaches back into the vault, checks whether the user has membership, pulls out the only data that the user is authorized to see, and displays it. So this is a key design decision. The PVWA holds the truth. The vault holds the truth, and PVWA is just the window into it. The PVWA is not the truth, my apologies. The vault holds the truth, and the PVWA is just the window into it. So inside PVWA, data is organized into sections like privileged accounts, policies, logins, like recordings, confirmation, and given like a user, and a given user only sees like sections and entries enters their permissions allow. If your environment has thousands onboard account and a specific user only has rights to one of them, all that they'll see is when they log in, an auditor by contrast. An auditor by contrast typically gets like access to logs, recordings, and reports, and not the credentials themselves, because auditing and using the account are different jobs with different permission sets. So, where does onboarding actually begin? Day to day, not directly on the vault through PVWA. You go to the portal, define a new account's username, password, and target IP, and PVWA pushes that entry to the vault for storage. Same for policy changes. You set up policy rotation inside of PVWA, and that setting gets written into the vault, which is what the next component reads from. So next we have CPM, the third component, the Central Policy Manager, or CPM, sometimes called a Central Password Manager. Both names are fine. The CPM's job is narrow and specific. It's password management, specifically automated rotation. So here's the risk it closes. Say an account is getting on board with the password XYZ. So it just stays XYZ indefinitely. The users who are authorized to use it already know that password. Nothing stops them from skipping CyberArk entirely. Opening an RDP client and connecting directly with a credential key memorized, you can't technically block RDP as a protocol. The only real defense is making the password something the user doesn't know and keeping it that way. So that means rotating the password after onboarding, then continuing to rotate it on schedule. That is what a good security habit looks from everywhere, not just in CyberArk, banking logins, admin accounts, and anything sensitive. Doing this manually doesn't scale. In an environment with thousands of accounts, having a person log in, change each password on a schedule is a full-time job by itself, and it has to happen in two places simultaneously, on the vault side and on the actual target machine. Because if those two fall out of sync, the login stops working entirely. So CPM automates the whole cycle. You define a rotation policy, say every 7 days, then the policy gets written to the vault. And when the scheduled day arrives, CPM picks up the account's current credential, and opens a direct connection to the target machine using it, and sets a new password there and updates the vault to match. So no manual step, no human touching either side. So yes, that was CPM. And next we have the Privileged Session Manager, also known as PSM, the fourth and last core component. So if CPM handles passwords, PSM handles connections. 3 jobs specifically: monitoring sessions, recording sessions, and isolating sessions from each other. So here's the full connection flow from end to end. A user logs into PVWA. PVWA checks their identity and permissions against the vault. If they're authorized for a given account, that account shows up. But here's the important part. The user sees the account name and the target IP, but never the actual password. They're already authenticated and authorized, so CyberArk knows they're allowed to connect. But the credential itself stays hidden. If they never see the password, they can't casually reuse it outside the tool. So the user clicks connect, and from this point, PVWA doesn't hand off the connection to CPM. The password management isn't relevant here. It hands it off to PSM instead. PSM, it starts monitoring, beginning a screen recording, and isolates the session so it's not visible to any other concurrent user. And then it brokers the actual connection to the target machine. So one detail worth knowing, when a session is active, that its logs and recordings are stored locally on the PSM server itself, which is why the PSM needs its own storage allocated. And only once the user logs off and does everything get shipped over to the vault for permanent storage. So there's clean division of labor when worth remembering. PSM generates and initially stores the data. The vault becomes its permanent home. The vault becomes a permanent home. And PVWA, it becomes it's an auditor where it actually goes and retrieves and to review it. So there's 3 different components and 3 different rules in one continuous record. So one more piece that is worth mentioning before we close is, since PVWA is the front door to the entire architecture, it's worth mentioning where you layer in multi-factor authentication. A user enters their credential, and before login completes, they're prompted for a second factor. A code, a push approval, whatever your MFA provides or requires, is a small addition, but it sits at exactly the right choke point. The one piece every user has to pass through no matter what they're trying to reach. So zooming out, here's the mental model we leave with today. The vault is the brain. Every component ultimately reads from and writes to it, and it's the only thing that actually stores anything long term. PVWA is the face, the interface every user and every policy's change goes through, and CPM is the hands for passwords and quietly rotating credentials on a schedule so static passwords can never become a liability. And PSM, it's the PSM is the hands for sessions, brokering every connection, recording it, and keeping sessions isolated from one another. And so 4 components, 4 distinct jobs, one vault tying them all together. So that's the architecture at the overall overview level. Next session we'll go one deep layer on Vault specifically and how it actually works under the hood. And after the theory is done, we move into the labs and starting installing these components ourselves. Thank you so much and have a great day. And also check out my website. It is a training app for a CyberArk Defender. It's a very good app and I think you'll love it. Thank you so much and have a great day.